So let's discuss a few concepts. Frank-Starling Law, preload, contractility, afterload, and diastolic volume and systolic volume. Let's do this. So Frank-Starling Law. Venous return related to end diastolic volume, related to stroke volume, related to cardiac output. What is a stroke volume? The amount of blood is being ejected with each contraction. However, the stroke volume equals end diastolic volume minus end systolic volume. So let's discuss end diastolic volume. So here's your ventricle. This is one ventricle, but it represents two ventricles. This is your heart, right? Left ventricle, right ventricle. That's where the blood is in before the ejection. End diastolic volume, the amount of blood that ends up in your ventricle during the diastole, during the heart relaxation, when the heart is relaxes. When the heart is relaxed, the blood fills the ventricles. So the blood from the H's end up in both ventricles. That's the end diastolic volume. How much of blood is in the ventricle before the ejection. And systolic volume, the remaining, the residual of blood after the ejection. So after the ejection from both ventricles, what are the leftovers? That's the end systolic volume. So the stroke volume, the ejection, equals end diastolic volume, that's how much of blood before the ejection, and end systolic volume, that's the leftovers. So this related to cardiac output. What is cardiac output? Cardiac output equals heart rate multiplied by systolic volume. Preload, let's say there's 120 milliliters of blood. Afterload, the leftovers, let's say there's 50 milliliters of blood. 120 minus 50 will equal approximately 70 milliliters. I said approximately because these numbers can vary. So your cardiac output is 70 milliliters. How do you calculate cardiac output? Heart rate, how many times your heart beats per minute. Cardiac output, the amount of blood is being ejected from both ventricles per minute. Stroke volume, one ejection. Frank-Starling Law. Let's look at this. The preload is dependent on the venous return. How much of blood is being returned from the system, right? So the blood we're returning from the system into the heart. So this is also called a preload. The preload and diastolic volume, how much of blood fills in the ventricles. So if you have increased preload, venous return, that leads to the increase in diastolic volume, the amount of blood fills the ventricles. That leads to increased stroke volume. It depends on how much of blood in here. And that can lead to increased cardiac output. That's a Frank-Starling Law. So, and diastolic volume, it is a preload. Preload and diastolic volume. Venous return or increased venous return leads to increased preload, leads to increased stroke volume. What is the afterload? That's a resistance. So for the ventricles to eject blood, they have to eject the blood against the force that's being applied on the valves. So the afterload is the resistance that the ventricles must overcome to eject the blood. There is a pressure. In previous ejection, there is a pressure on the... So let's say during the diastole, that's right before the contractions, the pressure is about 80. And the ventricles must overcome this pressure. So they have to eject the blood with approximately 120. That's an average with healthy males and females. This is a diastole. This is the systole. The pressure the ventricles must create in order to open those valves. This is the afterload. resistance. That's a resistance. And the last one is a contractility. Contractility is the ability of myocardium, of muscle cells, to contract at the given preload that is independent of the shock volume. So at the given preload, it doesn't matter how much of blood in here, it's just the ability of the myocardium to generate force in order to eject the blood. It doesn't matter, it's independent of the shock volume. So look at this like a spring, like squeezes, how the myocytes will squeeze. So let's say here's the spring, right? And it needs to eject the blood. So it doesn't matter if there's a lot of blood or there's a little bit of blood, it has to generate pretty much the same amount of force in order to eject this amount or this amount. Alright, so let's try to summarize everything. Ventricle, venous return, and diastolic volume, stroke volume, the pressure that has been exerted on the valves, and the pressure that the ventricles must create in order to open those valves, and systolic volume, amount of blood remaining after the ejection. So in Frank-Starling Law, venous return related to end diastolic volume, preload, related to stroke volume ejection, related to cardiac output, how much of blood is being ejected. And this is the leftovers. We need to keep certain amount of blood within the ventricles, otherwise ventricles may collapse if you will completely empty the ventricles.